up on that enough. Let's talk a little bit more about how this balancing works. And this starts with a very important consideration, which is bypass airflow. And we're going to look at a number of slides here that show the airflow volumes through the room. So this is a simplified example of a room that has one cooling unit and 2 rows of IT cabinets. And so generally the airflow, volumetric flow rate of air through cooling units and IT equipment is in North America is considered in terms of CFM, cubic feet per minute. And a cooling unit might have, 10, 15, 20,000 CFM. But we're going to keep the numbers very simple and say that all the air moving through all the cooling units in the room is 10 units of air. So if 10 units of air go down into a cooling unit, 10 units come out. And as long as the subfloor plenum is sealed, if you add up all the air coming out of all the holes in the raised floor, it's going to add up to 10. So in this case, we have 2 units of air coming out of unsealed cable openings under this row, 2 units of air coming out of unsealed cable openings in this row, and 6 units of conditioned air coming out of supply tiles in a cold aisle where it should. So 2, 8, 10 units of air coming out of the raised floor. When we look at the cold aisle, we see that this row of cabinets, all the IT equipment in this row of cabinets consumes 2 units of air, and this row also consumes 2 units of air. So the demand for the IT equipment is 4 CFM in this cold aisle, but we're delivering 6. So that means there's 2 extra units of conditioned air delivered to this aisle that's not needed. And that extra conditioned air leaves the aisle as bypass airflow. And we get our total of 10 units of air flowing back to the cooling unit. So obviously we want to seal these bypass openings, right? We want to block this bypass airflow. Absolutely. And do you think that if we seal this opening, these openings, and block this 2 units and this units of air, so here's a question to answer, will that affect how much bypass airflow is in the room? It's a trick question, kind of. The answer is, well, yes, it limits the amount of bypass airflow coming out of the raised floor underneath cabinets, but it doesn't change the amount of bypass airflow in the room. We're now delivering all that conditioned air is coming out of supply tiles in a cold aisle, but the IT equipment still only needs a total of 4 units. So now there's 6 units of bypass airflow leaving the cold aisle. But this is still a good thing. We're stepping in the right direction because now we've created an environment where we can make adjustments to the set points and reduce the amount of air moving through the cooling units. Now take it down to 5 units of air so that we're delivering 5 units of air into the cold aisle. The IT equipment needs a total of 4, and we've got 1 extra unit of conditioned air. Always good to have a little extra for variations in flow rates through IT equipment and have a little slight positive pressure. And now we've reduced the flow rate through the cooling units by half. And that has a dramatic effect on the energy consumed by those cooling units. So let's, just before we go on to that, I want to say, this is the amount that we can reduce the fan speed is dependent on how much airflow management has been implemented in the room. We couldn't do this if there were missing blanking panels in these cabinets. We couldn't reduce the fan speed by half and and very closely match the flow rate through the cooling units to the demand flow rate of the IT equipment if there's supply tiles in the wrong locations, if there's air flowing underneath cabinets, if there's hot air flowing around the ends of the rows. So the more containment we put in place, the more we can optimize and more closely match the flow rate moving through the cooling units to the flow rate moving through the IT equipment. And they are independent. If you turned off all the cooling units in a computer room, all the fans in the IT equipment, assuming they're all in UPS, of course, will continue to operate, and they will continue to move 4 units of air through all the IT equipment. Totally independent of the amount of air moving through the cooling units. And what if you added 5 more cooling units in this room? There would still only be 4 units of air moving through this IT equipment. So the amount of air moving through the IT equipment and the amount of air moving through the cooling units is independent and separate. And we want to create an environment where we can as closely match those two as possible.